sure I lowered this microphone because I'm nowhere near that. All right. Y'all, thank you so much. Good afternoon. It is a pleasure to be with you. Like Matt said, my name is Cullen, and I am the Woodworks Regional Director for the states of Georgia, Alabama, Mississippi, and Louisiana. I am based in Atlanta, in Decatur specifically, so not too far away. So like I said, it's a pleasure to be with you today. Talk very quickly about a little bit about myself. I'm a structural engineer by training. I have about 7 years experience. The vast majority of my experience is type 3, type 5, mixed use, multifamily. For those of you that are here from, that live in Columbus, or you can't get that out. If you are from Columbus, I worked on the Rapids at Riverfront Place project, right on the river, if you're familiar with it. So anyway, so let's go ahead and get started. So today is an overview of mass timber for everybody to make sure we're all on the same page. What is CLT? What is DLT? So forth and so on. We're going to look at a couple of case studies, a couple of example projects, and we'll talk very broadly about what the building code has to say, construction types, fire ratings, so forth and so on. I want to make sure, please, if you have any questions, please feel free to ask them as you think of them. Please don't wait till the end. Okay? So for those of you who are not familiar, Woodworks is a nonprofit, and our sole objective is to assist architects, structural engineers, contractors, and developers with their wood projects. Now that could be light frame, mixed use, multifamily, or that can be mass timber. So like I said, I'm a regional director for 4 states here in the southeast. There is someone like me all across the country, right? And so we provide project assistance and education at events like this on mass timber and light frame wood construction. So you will meet him here shortly, Bill with St. Alban with Sizemore Group. He is going to be talking about the beautiful city, Brookhaven City Hall project. So I worked with his group extensively during the course of design and construction of that project. So one thing about Woodworks, we are a nonprofit. We have lots of resources on the woodworks.org website. They're all absolutely free of charge if you are interested in learning more about mass timber. So as we are a nonprofit, we always like to thank our funders. Our funders are the Softwood Lumber Board, USDA, U.S. Forest Service, as well as Forestry Innovation Investments. Additionally, we have these other partners, right? One of which is sitting in the room today, Smart Lab North America, and you will be hearing from Derek here in just a bit. All right. So, like I said, we're going to do this as an overview of mass timber. What are the products in mass timber? What sort of buildings can I build with it? How tall can I build with it? And look at some example projects. So, all right. So when we're looking at building construction, we're usually looking at 3 different types of wood buildings, right? The image on the left is light wood frame. We're all used to that. That is 2x4, 2x6 studs with your floor system, roof system of choice. That can be joists, that can be trusses, whatever the case may be. We see that a lot in single-family residential. We also see that a lot in our mixed-use multifamily apartment buildings, right? The image in the center is what we call heavy timber. Now, what sets heavy timber apart is the use of solid members, right? A 6x6 post, a continuous solid member. We don't see this type of construction as much anymore. And then finally, the image on the right is what we call mass timber, right? And what sets mass timber apart is the use of laminations, right? So we have glue lams where we have a 2x member laid flat, a layer of adhesive, and then another 2x placed on top of that. So we get the depth that we're looking for. So that's really what sets mass timber apart, is the use of laminations. All right. So I did mention glue laminated timber, the one on the left. We also have CLT, cross laminated timber, and we'll step through all of these here in just a second. So we have CLT that is made with regular dimensional 2x lumber, 2x4s, 2x6s, whatever the case may be. We also have cross laminated timber that is made with structural composite lumber laminations. So specifically LVLs, or laminated veneer lumber. Okay? Dowel laminated timber, nail laminated timber. And again, don't worry, we're going to step through all of these, so I'll explain them all, right? And finally, we do have GLT, or glue laminated timber, and these are our glue lamps just rotated on their sides, which we can use for floor and roof panels. Right? Start with our glue lamps, our glue laminated timber. Yes, sir?
Quick question, why dowel? What are the benefits of that versus the other types?
We'll get there in just a second.
Okay.
We'll get there in just a second. All right, let's go ahead and get started with glue laminated timber. So like I said, these are our 2x members laid flat on their flat face. We place a layer of adhesive between them, and then we place another 2x on top of that until we get the depth that we're looking for. We typically use these for our beams and columns in our buildings. We can, like I said, we can use them for floor and roof panels when we rotate them 90 degrees. We can pressure treat these glue lamps. To my understanding, we can also fire retardant treat them. One good thing about glue lamp is that you have flexibility with glue lamp. You can curve them, you can camber them. So you have a lot of flexibility in terms of shapes. It can actually be a quite elegant product. Okay. Nail laminated timber. Now we're looking at floor and roof panels. Nail laminated timber is very straightforward. So these are 2x members laid next to each other on their short face, so the long direction is like this, right? And what we do is we put these 2x members together and we nail them together at a specified nailing pattern, right? And we can use these for floor and roof panels. Okay. Nail laminated timber in the building code is technically classified as decking, so NLT is in the building code. Okay. We do have an NLT building here in Georgia, in Atlanta, and Matt referred to this project just a few minutes ago. This is the Candida Building for Innovative Sustainable Design on Georgia Tech's campus at the corner of First and Hemphill. So this is the only Living Building Challenge certified building in the state of Georgia. So if you're familiar with Living Building Challenge, it is like LEED Platinum Plus. This is a 2-story building. It has glue lamp and nail laminated timber for the floors and roofs. So it's really interesting. They fabricated these panels on site, all from reclaimed wood. And what's interesting is that all the wood that was used in these NLT panels in Candida came from movie and TV sets across the state of Georgia. As you can see here, this 2-story building, 37,000 square feet, completed in 2019. I always like to show that shot because it shows the interior, the underside of the NLT. All right, moving on. Dowel laminated timber. The dowel laminated timber is very similar to NLT in that you lay your 2x members next to each other on their short face. While they are still moist, you drill a hole in them and insert a hardwood dowel. Now, as that moisture content comes down in those 2x members, that hole gets smaller, the dowel takes on the moisture, and you have a hard connection. Okay? There is no building code recognition for DLT at this point. There is currently only one manufacturer of DLT in North America, and that is Structurecraft in Vancouver, in British Columbia. We do actually have 2 DLT buildings here in Georgia, both of them in Atlanta. One was one that Matt just referenced a minute ago, T3 West Midtown, in the Atlantic Station neighborhood of Atlanta. The other project was recently completed, Campus 244 in Dunwoody. So it is right near Perimeter Mall. As you can see, it is right up against I-285, so it's quite a prominent location. I almost had an accident on I-285 the first time I saw the timber.
There's something interesting about this one I'd like
Yes.
to point out, because mass timber is stronger and lighter than steel or
Yes.
concrete, a little bigger. And so this was all put on top of an existing building.
Yes, so this was,
So when I worked with Jamestown a little bit, they saw all this real estate they owned across the country. They could start adding floors to it with mass timber if the structure was strong enough. And here, that was the theory about 5 years ago, but now it's nice to see one here in Atlanta.
right, so this is considered a vertical addition. So this is 2 stories of glulam posts and beams and DLT over an existing 3-story concrete building. So one thing that was really interesting about this project, and Bill just alluded to this, mass timber is significantly lighter than steel or concrete, significantly lighter, to the point where they added 2 stories on top of an existing building and did not have to touch the foundations.
Oh, sorry, I didn't mean to take your.
I told you before we started that I was just gonna let you do this, right? So it's a gorgeous project, it's easy to see from the interstate. All right, moving on, cross-laminated timber. So for the rest of the presentation, we're gonna be focusing on our dimensional lumber cross-laminated timber. So when I say CLT, I mean the dimensional lumber cross-laminated timber, right? So this product is very similar to plywood, right? So what we're doing is we have 2x members laid on their flat base next to each other. We place a layer of adhesive, and then the layer on top of that is rotated 90 degrees. Right, we got a couple of benefits to doing that. One is that we have strength in 2 directions. So it's possible for us to have what we call 2-way action and eliminate some beams in some cases, right? Panel widths are typically about 12 feet wide, 60 feet long, varies by manufacturer, right? We typically use these for our floor and roof panels. We also can use them for walls, for bearing walls. Okay, this one I did mention briefly with the CLT, with the structural composite lumber laminations. This is thin layers of LVL or laminated veneer lumber. This has some very interesting applications in multifamily, in high-rise multifamily. Currently, there's only one manufacturer of this product, and they are out in California. But they have some interesting products. All right, so cross-laminated timber is defined in the International Building Code, starting with the 2015 version. Right, so we do absolutely have a code precedent for CLT in the building code. Right? Talk about an example project, and Matt referred to this project just a minute ago. I actually left a tour of this building this morning to come down here. So this is a 619 Ponce project on Ponce de Leon Avenue in Midtown Atlanta. So this is 4 stories of glulam and CLT over a 1-story PT concrete podium. It finished up Q1 of '24, and then Pottery Barn, as you see on the ground floor, opened up in April of last year. But this is a really innovative project, and I'm sure we can all talk about 619. I'm sure Derek will talk about that a bit more during the panel discussion. So yeah, so the bottom floor is Pottery Barn, so it's retail on the ground floor, and then office, the top 3 levels. Levels 3 and 4 are currently leased to a software firm called Sage. Level 2 is currently unoccupied. All right, so let's talk about the types of buildings we can build with our mass timber products. So obviously what we can do is what we call post beam and plate. This is where we have our glue lam beams and columns along with your mass timber panel of choice, CLT, DLT, whatever the case may be. Obviously we can do that, right? We also have what we call point supported or posts and plate. Now I referred just a minute ago when I was talking about CLT, I talked about how in some instances we can shallow up the columns, the span between columns. And because of the two-way action of those CLT panels, in some instances we can eliminate beams altogether, right? This is an awfully appealing option in multifamily when you can hide columns and interior walls, demising walls, that sort of. Okay. Another option is what we call honeycomb. This is all mass timber bearing walls with mass timber floors and roofs, right? So this is the photo that I'm showing here is actually outside of Huntsville, Alabama at Redstone Arsenal. This is a hotel. This is a hotel. These are CLT bearing walls with CLT floors and roofs. Now what's really interesting is that these hotels are, the Army actually built these hotels, built multiples of them across the country. They are privatized Army lodging. And a big reason why the Army built these projects is because of mass timber's performance in blast design, its impact resistance. We do have a couple.
Sound transmission. Sound transmission room to room.
Yeah, we'll talk about that in just a second. Yeah, we're going to talk a little bit about these things. So we do have some hybrid options as well. We can absolutely do 2x4, 2x6 walls with mass timber floors and roofs. This is a popular option for multi-family projects. You can expose the underside of those panels and charge more rent. Okay, you can absolutely do that. You can also build steel and mass timber, right? Steel framing, steel beams and columns, along with whatever panel you choose to use. There is an example of a steel CLT hybrid in Atlanta in West Midtown. It is the office building for Echo Street West. Smartland provided they supplied the Southern Yellow Pine CLT panels in that project, and it's actually quite beautiful. The steel framing is painted a matte black, and it's just really pretty.
Just curious, fire rating on that assembly, the floor ceiling assembly, what are you typically getting?
Everybody's asking me the questions that we're going to get to. We're going to talk about fire rating in just a second. Yeah. Especially when we are looking to expose that mass timber. How is it that we satisfy the fire rating? But we'll talk about that in just a second. All right. So when I talk to design teams about mass timber, right, I often ask them to define their why. Why is it you want to build your building with mass timber? What is the appeal? Is it the aesthetics, the concept of biophilia, the concept of bringing the outdoors in? Is it sustainability? Is it I can build my mass timber building faster and get people in it faster? Is your motivation possibly that you believe you can charge more rent? So, so we have talked about 619 Ponce and the owners, Jamestown. What Jamestown won't commonly say is that 619 Ponce recently broke the leasing rate record for the city of Atlanta in its history, with the leasing of sage on levels 3 and 4 of 619 Ponce, over $70 a square foot. So, and it's not just 619, we can also demonstrate in multifamily buildings where mass timber is being used. Ann Street down in Savannah has a premium, charges a premium for those units, as well as multiple other instances across the country. You know, but so what is your why? You know, are you dealing with a site that has troubled soils? Are you considering mass timber because it's so much lighter, therefore less site work, less excavation? Okay. So some things to think about. So mass timber has several benefits to it, right? Aside from the aesthetics, aside from the sustainability, right? One is construction time, right? All of these components are manufactured and fabricated off-site. They are literally trucked to the site, those components are literally trucked to the site and then dropped into place, right? That provides a significant, can provide a significant cost savings during construction, right? Because you're not having to pour concrete, you're not having to set up formally and let it cure for 21 days or however long, right? So you're prefabbing, you're manufacturing, you're doing all this off-site, you are trucking these components to site and dropping them into place. So obviously you have a construction time savings, you also have a significant labor savings, right? So again, going back to 619 Ponce for just a second, when 619 was under construction, there was another concrete building being constructed at the same time, 22-story building called Scout Living. It was constructed at the same time as 619 Ponce. They shared a tower crane, which I'm sure must have been lots of fun from a logistics perspective. So on site at Scout Living on the concrete building, they had on average 120 workers on site every day. On 619 Ponce, the maximum number of workers they had on site every day, the maximum was 8. So it's a significant labor savings as well, right? So you're spending a lot less time in construction. That means you're turning this building over to the owner faster, and that means that the owner can get tenants in quicker and potentially start charging them more rent as well. I always like to talk about this project. This is the Brock Commons project in Vancouver, British Columbia. This is a dormitory for the University of British Columbia. It is an 18-story glue lamb post and CLT project. 18 floors. So they were able to install 1 floor of glue lamb and CLT every 3 days. All 17 floors over the course of 9.5 weeks, right? And this is not a small footprint building, right? So again, the material mass, because mass timber weighs so much less than steel or concrete, that means that our foundations can be smaller. That means less site work, less excavation, right? It's what allows us to put 2 stories of mass timber on top of an existing building and not have to touch the foundations. Okay, and again, the reduced embodied carbon. Now what is embodied carbon? Embodied carbon is the amount of carbon that is released to the atmosphere during the creation, the manufacture of our building materials. Okay? Our wood products have significantly less embodied carbon associated with them than steel or concrete, right? We don't have to heat steel we don't have to heat our wood to an extremely high temperature like we do with steel or cement for that matter, right? So therefore we have a lot less carbon associated with the creation of our mass timber building. Not only that, but the concept of what we call biogenic carbon. Now let me go back to elementary school science for just a second, right? The process of photosynthesis. Remember when our plants, our trees take in carbon dioxide and then oxygen is released back out into the atmosphere. That carbon is stored in that wood component for the life of that component. Okay? So wood is actually 50% carbon by dry weight. So not only do you have the embodied carbon reduction, but you also have the biogenic carbon, the carbon that is stored in that wood for the life of that component. Right? Talk very quickly about construction types. For my non-architects and engineers in the room, I'll talk very quickly about this. There are 5 construction types in the International Building Code. Types 1 through 5. Type 1 is the tallest. Type 5 is the shortest. Our wood components are typically seen in types 3 and 5, right? Are what we call stick frame. So our 2x studs or trusses or joists, that kind of thing. That's typically where our wood components live, right? However, we can use mass timber in types 1 and 2. Now, footnote C of table 601 allows us to have mass timber and its supporting construction at the roof in types 1B and type 2. Right? We're seeing this utilized a lot in airports, of all things, right? Huge square footage, perhaps not terribly tall, but the square footage is huge, right? For those of you that are familiar, the Portland, Oregon airport, they recently opened an expansion of the Portland, Oregon airport, which was completely done in mass timber. It's absolutely gorgeous. Okay? So type 3 is our taller wood construction type, right? Type 5 is our shortest, right? So I say this to say we can have mass timber in all 5 construction types, right? Regardless of how short or, well, there is a limit to how tall we can go. But we'll talk about that in just a second, right? So we can absolutely have mass timber in all 5 construction types, right? So for my architects and engineers in the room, you probably know that the state of Georgia is currently on IBC 2018. We are due for an update, and I believe the current plan is for IBC 2024 to take effect with an effective date of January 1st of next year. Now, in the 2021 version of the International Building Code, we have 3 new construction subtypes, which are specific to mass timber. These are what we call the tall mass timber construction types. Starting on the left, type 4A, the tall one, up to 18 stories and 270 feet tall. Type 4B, the one in the center, is up to 12 stories and 180 feet tall. Type 4C, the one on the right, is 9 stories and 85 feet tall. Now, the building code does restrict us with these taller mass timber construction types. So say, like, for example, with the tall one, type 4A, the building code requires us to completely cover the mass timber with some sort of non-combustible covering, right? With type 4B, they require us to have certain percentages, right? So it's up to 20% of the ceilings or 40% of the walls, or a combination of those two. Finally, type 4C, you can leave it completely exposed with a few minor exceptions, right? There are no restrictions on coverage in type 3 or type 5. It's an important point. So you may be saying, well, why do I care about this? This is an IBC 2021. Georgia is on IBC 2018. Alabama is still on 2015, I believe. So why do I care about this? Well, as it happens, these construction types, these tall construction types, are actually an addendum to our current building code. It's called Appendix P. And that was actually effective January of 2022. So we have code precedent to build tall in Georgia right now. Okay. Any questions before we move on? Okay, all right. So you asked this question just a minute ago. What about fire resistance? What about fire ratings? Right? How is it that we demonstrate our fire ratings for our mass timber components, especially when the building code allows me to expose a lot of the wood? And my architects often want to expose as much as they possibly can. Right? So what we know about our wood building components, there's been extensive testing done, right? We know the rate at which it burns. We know how it burns. We know that as a wood component burns, the outer layer of that component chars, and then that char layer insulates the inside of those components, right? So the International Building Code in section 722 allows us to go to chapter 16 of the National Design Specification for Wood Construction. That is the wood material standard for your structural engineers. And what it allows us to do is what we call char calculations. It allows us to calculate the amount of char that will be generated on a given wood component for a certain amount of time, right? They have these fun charts, and it's based on the component itself. A glulam versus CLT versus dimensional lumber versus LVL, right? So a good rule of thumb is 1.5 inches of fire rating per exposed face per hour of fire rating. So that means that you have to increase your cross-section by that amount to obtain your fire rating, right? And so what your structural engineers are doing, they're actually checking both that larger cross-section as well as the diminished cross-section after a fire event to make sure it can still support the loads it's designed to support. So on the Woodworks website, we do have this inventory of fire-tested mass timber assemblies. This is actually one of my favorite documents on the Woodworks website. Sorted by manufacturer, and it gives you fire ratings based on specific assemblies. Okay. Any questions before we move on? Any questions? Okay, all right. So the next topic that we're going to talk about is acoustics. Acoustics in mass timber, right? So I have highlighted the fact that mass timber is significantly lighter than concrete or steel, which is great when you're looking at foundations, when you're looking at excavation, but perhaps not so great when we're looking at acoustics, right? So oftentimes what we have to do is we have to give our mass timber a little help. Now, very quickly, I'll talk very quickly about how we rate acoustics in our mass timber buildings. We'll talk about STC, sound transmission class. That is me speaking to you now and the person in the next room can hear, right? That's STC. The higher the STC, the more difficult it is to hear. Also, we have IIC, impact insulation class. That is someone on the level above, walking around with hard-soled shoes on, heels, that sort of thing, right? So particularly in multifamily occupancies, we have minimum STC and IICs to hit. A minimum STC and IIC of 50, specifically in our multifamily occupancies. However, a plain CLT panel only has an STC of 38 on its own. So it needs a little help to get where it's going, right? And how do we deal with the acoustics when we're trying to expose as much of the panel, these components, as we can, as we are allowed to by the building code, right? So for a typical floor assembly, right, when we have a CLT panel, right, typically we're putting on top of that some sort of topping slab, right? Concrete, gypcrete, whatever the case may be. An acoustical mat, which my architects are intimately familiar with, right? With structural panel, if your engineer requires it, and then your finished board on top of that. So those components combined will get you your minimum STC and IIC that you're looking for. So Woodworks also does have on our website an inventory of mass timber acoustically tested mass timber assemblies. So again, it's sorted by manufacturer, right? So it's sorted by manufacturer, so it will give you an STC and IIC for that specific assembly. All right, talk very quickly about lateral systems in our mass timber buildings. Talk very quickly about it and what the building code does and does not allow. Particularly with our tall mass timber buildings, we are looking at concrete shear walls for our lateral systems. Right? They are typically poured. They're typically poured all in one shot, and then the mass timber comes in behind it. Now, there are some considerations when you are using concrete shear walls for your lateral system. The problem is that these mass timber components are very precise because they're manufactured in a manufacturing facility. Tolerances are very small, right? That's all well and good, but it becomes a problem when your concrete wall is 4 1/2 inch out of line. Okay? So, we can absolutely do mass timber shear walls, CLT shear walls. We can absolutely do that. Seth, is this Clemson?
It looks like it, but I'm not sure based on what's outside.
I apologize, y'all. This is Seth Adams with Brent Peters Associates. He is the engineer for Brookhaven City Hall. So he also worked on the project I was just asking him about. It's the Andy Audubon Center at Clemson, South Carolina, and they used CLT shear walls on this project. Okay, we can absolutely do steel moment frames, steel brace frames in our mass timber buildings. Typically, we wouldn't see brace frames quite that large on this side of the country unless we're going towards Memphis or Charleston. Okay, we can absolutely do our sheathed wood stud walls like a lot of us are used to in our mixed-use multifamily buildings. All right. So all of those options are currently allowed by the building code, with one exception, but it's coming, and that is the CLT shear walls. Y'all bear with me for just a second. So CLT shear walls show up in SPIDWIZ 2021, therefore ASCE 722, therefore we do not see them in the International Building Code until the 2024 version. They are approved then. So you absolutely have a precedent for using CLT shear walls in your buildings, if you would like. All right, my final topic of today, and I'm about done, so I will make this one quick. Connections. You've got a lot of different options when it comes to connections, right? You can have custom connections, you can have more of an off-the-shelf type connection, right? So what the building code requires you to do is that the connector itself must have the same fire rating as the components that you are connecting together, right? Must have that same fire rating. And there are multiple ways to accomplish that, right? Oftentimes we're seeing concealed connectors where the wood that surrounds that connection provides that fire protection. Okay? That's one of those concealed connectors, right? Being column connections, this one on the left that I'm showing here, is a knife plate in the back with a seat. And remember, that still has to have a fire rating, so you may have to put some incandescent paint on that if it's greater than, if it's an hour or greater. All right. Panel to panel connections, there are several ways to do this. So you're connecting your mass timber panels of choice along that joint, right? So you can either notch out the length of that panel and then put in a plywood spline and screw that in. Or there are now metal spline options that do not require that notching out of the panel. So I've heard pluses and minuses to both. Okay, finally, our column to foundation connections. So this one's unusual, or this one's a little different. This is a standoff plate or a standoff base, right? So in this case, the glue lamp column sits directly on top of that plate, and you screw it in. The reason for that, the reason why we have that wood stand off is because of moisture. Okay. I believe that's all I got.